I am very glad, it is with great pleasure that I present Dr. Athena Demertzi, because she's also Greek, like me. She has studied psychology and cognitive neurosciences, has fulfilled her PhD at the Coma Science Group of the University of Liège in Belgium, and is currently working as a postdoctoral researcher in the ICM Brain and Spine Institute in Paris. And the title of her talk is Functional Neuroimaging in Patients with Disorders of Consciousness and What to Care About. Athena, welcome, καλώς ήρθες, on behalf of Aix-Marseille University and our PhD program.
Thank you so much for... Thank you so much for the invitation. It's a great pleasure to be in Marseille in this day. As it was said, my background is psychology, so today I will share with you the work and research we do in Paris and before in Liège with patients with disorders of consciousness, and I will show you how dealing with these patients we have implications at the clinical, scientific and ethical level. But before talking about disorders of consciousness, let's define what is consciousness so we have a common framework. And I'm sure that if I ask any of you in here what is consciousness, most probably you will give a different definition because it's something very intrinsic and personal. In order to avoid any miscommunications, let's define consciousness operationally. That is defined by two components. Wakefulness, that at the bedside we evidence by eyes opening, and awareness, that we can infer by command following. So based on this definition, all of us should be around here, unless you partied hard last night. So we see that as the level of wakefulness goes down, so does the level of awareness, meaning that during deep sleep, we're not conscious because we cannot be awakened. Exception to this rule applies to REM sleep, because during this condition, this state, our brain functions almost at normal level, but still we are not. We cannot say that we're normally aware. Again, people under anesthesia and patients in coma, they are not conscious because they cannot be awakened. An exception to this rule comes from patients in the so-called vegetative state or unresponsive wakefulness syndrome. This is because these patients will open up their eyes, but they will show no evidence of themselves and the environment, and they will not respond to any sensory stimulation like visual, auditory, tactile, and so forth. Some years later, that was in 2002, we had the introduction of the minimally conscious state. The minimally conscious state was introduced to describe some of the atypical vegetative unresponsive patients because they would show more complex behaviors, like command following. From time to time, these patients will follow a command like close your eyes, they would do it, but inconsistently time. And they will show also non-reflex movements, like for example, visual pursuit. Having an object in the visual field, they will follow it, which is atypical for the vegetative state patients. And our work is to shed more light into this gray area, the gray area that is covering patients that we cannot tell whether they belong to either this or the other category. And this is important because not only clinically, but because people think differently about these two conditions. And how do we know that? Because we asked them. We went for like 2 years at conferences and meetings in Europe with a bunch of papers, questionnaires that we delivered to the audience like you. And we asked, no, I will come back to that, people different questions about these two categories, vegetative and minimally conscious state. And we asked for their attitudes about ethically related issues. For example, pain. Pain is a subjective experience that, because it's so personal, it means that somebody must be there in order to experience something painful, noxious as pain. So we asked people at meetings whether they think that patients in a vegetative state or a minimally conscious state feel pain. What we found is that the majority of respondents agreed with minimally conscious state patients experiencing pain more than patients in the vegetative state. And when we try to figure out where these attitudes come from, we found that it's mainly some personal characteristics like the professional background and having a religious affiliation or belief that would influence your attitudes with agreeing more with the statement that vegetative state feel pain or whether minimally conscious state feel pain. When it comes to more ethically related statements, like when it comes to end-of-life decisions, we analyzed the opinions of medical and so-called paramedical professionals to the question whether it is acceptable to stop treatment in a chronic vegetative and minimally conscious state. And at the same time, we asked if you see the same question, but this time concerning more about themselves, making it more personal, where they would be liked to be kept alive if they imagined that they were in a VS or a minimally conscious state. So what we found is that the majority of respondents agreed with treatment withdrawal for the VS, and they also wished not to be kept alive if they imagined themselves in this condition. Interestingly, when it comes to the minimally conscious state, we found that although the majority did not find it acceptable to stop treatment, if they imagined themselves being in a minimally conscious state, they would not like to be kept alive. And the variables influencing those attitudes had to do where you come from Europe. For example, northern respondents coming from North Europe would be more liberal to stop treatment as compared to the southern. And last, we asked how they consider these two conditions as opposed to each other, and as how they define the relevance about the patients and the families. So it was interesting to find that when it comes to families, the respondents found it that VS is worse than death, and this is more relevant for them than the patient themselves. But when it comes to the minimally conscious state, most possibly because they are more conscious, this is relevant more for the patient themselves. And then when we asked ourselves, so how would that be that when people ascribe pain to these patients would influence their attitudes toward end of life? So we found a negative association, meaning that when the respondents agreed that there is the experience of pain, they would be less willing to withdraw treatment from these patients. And these studies show, indeed, that people think differently about these two conditions. And now we are trying to better understand what is a conscious behavior. And how we do that at the bedside, and we also try to do that at the level of the brain. So to diagnose clinically a patient at the bedside is not easy. As you will see that in order to say that somebody is conscious, so let's say to infer cognitive capacity in the patient, we have to, we are depending on the motor responsiveness of a patient. So patients in coma, we think they have no cognitive capacities just because they cannot show any motor behavior that they could be evidencing their level of consciousness, the consciousness content. But once they open up their eyes, they're said to be in a vegetative and responsive state. And once we have some type of awareness that would be a response to a command or reflex movements that I said before, they are said to be in minimally conscious state. And interestingly, when we're able to communicate with them in a meaningful and functional way, they're said to be emerging from a minimally conscious state. But this means that they recover consciousness level, but it doesn't mean that they recover physical functioning. That's why most of them, they will find themselves severely disabled, but by means of neuroprosthetics or any other technological assessment, they can even get towards full recovery. So as I said, evidencing awareness at the bedside is not easy, not only because of the behavior we are assessing, but the way we also assess it plays a role. Here, visual pursuit, for example, is one of the main signs that indicate the minimally conscious state from unresponsive state. And the way we assess it plays a role. So here we show that when you present a mirror in front of a patient, you have more chances that the patient will track their image in the mirror than when you go around the bed or when you use an object in order to assess the visual pursuit. And all these little details that obviously they are meaningful are important because we can, like that, minimize the level of misdiagnosis in the unresponsive state. For example, here we show information of 103 post-comatose patients who came to the clinic with a clinical diagnosis of the vegetative state, 45 of them. And when we did a standardized assessment, here is the coma recovery scale, that is the standard scale that we use in the clinics, 25 of them, they were in a minimally conscious state. So this means that 40% of these patients have been misdiagnosed. And now we understand how and why the clinical assessment has its intrinsic limitations. That's why we're trying to understand what happens in the patient's brain in order to differentiate these two categories. So here I will talk about functional neuroimaging, functional MRI specifically, and how we can use this technology in assessing covert awareness in patients. Are you all familiar with functional neuroimaging in cognitive neuroscience? So, as you know, these are not flames in the brain, right? They are statistical maps, color-coded, showing the importance of an area being involved in a certain task or that you're executing. So in neuroimaging, in functional MRI, we have several ways to investigate people's minds and brains. We have active paradigms. This means that we ask somebody to imagine to do something actively, and then we measure the response at the brain level. Here, for example, we see the brain response to the question, to the task, imagine that you play tennis. And we see activation of middle cingulate cortex and a supplementary motor area. At the same time, when we ask a different task, like imagine that you visit the rooms of your house, we see activation of the parahippocampal place area. And these two tasks were found to have these distinct responses in each and every healthy individual that we assessed. And then we said, okay, since it's so distinctive, how would that be that we ask patients this type of question? With the premise that if we see something similar, then we have good reasons to believe that the patient understood the task and executed it. So this is what we did. We asked patients in disorders of consciousness that were scanned awake to do these two tasks. And out of 54 assessed patients, we found that 5 of them, they could do the task. We found this kind of activation in each of them. And what was interesting it was like with one of them, we could establish a channel of communication, a brain-machine interface. So in that case, we used the tennis paradigm to, as an answer, as a yes answer, and the navigation paradigm as a no answer. And the patient was asked different questions, mainly autobiographical questions, like, is your father's name Alexander? Is your father's name Thomas? So obviously, this patient, by doing the tennis, replied that the name is Alexander. So here we see that we are, the patient could say yes, no, no, yes, very distinctly in most of the questions. Only in the last question we could not get a reliable answer, most possibly because the patient fell asleep. What we see from this paradigm, though, it's like we have some constraints, and these constraints come from the negative findings. What if the patient does not respond to these questions? Can we say that this patient is unaware, is unconscious? We cannot say that, because it can be that they suffer from aphasia. It may be that they don't understand what we're asking, or they don't have the capacities to respond because of aphasic symptoms. Indeed, like when we try to indirectly assess aphasia in these patients, we found that if we see here, there's a difference even in the minimally conscious state. Here we see the minimally conscious state plus. This would be patients who respond to commands, and MCS minus, that they don't show this language-related capacity. And we saw here that for the minimally conscious state plus, the command following would encompass areas at the left hemisphere, language-related areas, Broca's, Wernicke's, that they're not present in those that they don't show this behavior. And this could account for a negative finding. So, in order to minimize this risk and get more power in getting something meaningful, we can use passive paradigms. This means that we use an external stimulation and then we measure the effect on the brain. For example, here, we did a study where we stimulated electrically the median nerve of the wrist, and we show how this stimulation that was noxious to healthy controls would be in patients' brain. So here we see the effect of the noxious stimulation of the healthy volunteers. We see the thalami, cingulate areas, insular, somatosensory cortices, which is a sharp contrast of what we find in the vegetative state, that the activation would be like kind of an island and disconnected from the rest of the brain. Whereas in MCS, they would be more widespread and would look more similar to those observed in healthy controls. Can we induce, though, that minimally conscious state feel pain? We cannot say that, because we miss the subjective report. Because pain, as we said, is something subjective, and it gives meaning to what it comes in. That is, so all we can say is that these patients have the capacity to process the incoming information to the way that can be consciously processed. Whether this can be painful or not, we cannot know. But again, the problems we have with the passive paradigms is that research institutions or clinical institutions may not have the means to do something more, something so complex. Or even some ethics committees will not give the permission to do something as painful in patients who cannot give consent. So we would like to do something more simple, the simplest as possible. You put a patient in the scanner for 10 minutes, you scan their brains, and then you try to make sense of what you see. And then you have the simplest paradigm as possible. So when we are scanning people's brains during resting state, it's not like the brain is silent. Even when you don't do anything, you're still doing things, like mental imagery, like mind wandering, like you project yourself to the future for the planning, or you recall memories of the past. And this happens spontaneously. It's an ongoing mentation. And this ongoing meditation has a neural substrate. To oversimplify it, we think that two networks, they can account for this mental function. The so-called default mode or internal awareness network, encompassing mainly midline structures, that is responsible for all these self-related cognitive things that we do. And a frontoparietal external awareness network, we see that these are lateral parietal areas, which are responsible for what we perceived through the environment, from our senses. And if we see how these two relate to each other, we find that one is up, the other one is down. So for the internal awareness, we see here the bold signal across time. We see its slow fluctuations across time. And it's the external awareness network anticorrelates to this function across time. And we think that this functionality is of conscious importance, meaning that this can account for subjective experience. But how can we apply this paradigm in patients? First, we need to understand what it means in healthy people, right? So in this study, we did a combination between behavior and neuroimaging, where we asked, here's the results of the behavioral study, healthy people, to give us a rating about their internal and external awareness every now and then. So here we see across time that at some specific points, they got a beep, like an auditory prompt, and they had to rate both their awareness levels from not aware, a bit, a lot, and total. And they were free to choose for each of them independently this rating. So what we found was something similar to what we observe also in the fMRI. So people, when they tended to say, I'm internally aware, more internally aware, they said that I'm less externally aware. And this anti-correlation was significant at the group level. And when we checked how much they swapped, it was on average every 20 seconds, similar to the bold signal. And then we said, okay, but which are the networks that would be encompassed, the areas? We put subjects in the scanner. This time we simplified the scale. We asked them from time to time to give us ratings from strongly external to strongly internal. And what we found was the following. When they were saying that they are internally oriented, areas of the default mode or internal awareness networks would be encompassed. And inversely, when they were saying that I'm more externally oriented, areas of the frontoparietal network were encompassed. So we started making more sense of the resting state, trying to bridge brain and behavior together. But then we thought, like, okay, so what if we modify the subjective state? How would the brain behave? For us, at that point, the best solution was to use to scan under a condition where we could still get subjective reports. And scanning under hypnosis seemed like a good idea. So the anesthesiologist from our group, she induced hypnosis in healthy people, and we scanned them under this hypnotic state and under two control conditions, doing an autobiographical mental imagery and not during pure wakefulness. So hypnosis was induced with I don't know whether you are familiar with the hypnosis research, but normally you suggest somebody to do something, like raise your hand and then they do it, or be a chicken. No, that is for stage hypnosis, okay? So in that case, we had an interview with the people, and then we asked them to recall a pleasant autobiographical experience. Mainly it was a vacation in Spain. It will not make me happy because I'm from Greece. But anyways, thing is that the hypnotist invite them to revive this experience from first-person perspective, whereas in this condition, they had to do the same thing just to recall the memory without the hypnotic induction. And as I said, this was the pure wakefulness. So first, we wanted to make sure that our subjects did achieve a successful hypnotic state, and we measured that by checking the dimensions of absorption, how much engaged you are in this state, and how much dissociated, disengaged you are from your environment. And we found that all people under hypnosis, they said that they were more absorbed during this state as compared to the controlled conditions, and they felt more dissociated from the surroundings, which went also with having less thoughts about their environment. So what happened at the brain level? The intrinsic system did not change that much, but we found profound modifications in the connectivity of the extrinsic system. So here we see from the frontoparietal area network that under normal wakefulness, as we defined before, and it is not much different from the autobiographical mental imagery condition, but in hypnosis it almost disappears. And this had also a behavioral counterpart, because under hypnosis, here, people would say, so we see time and the awareness score, that they were more often internally oriented than externally. And here we see that these two, external and internal, they tend to change a lot. And they tended to be in this condition longer than the external. So having studied the resting state in normal conditions, we were more confident to study what happens in the patient's brain. The premise is that if we find modifications in the networks that we recruit, maybe this would be of cognitive relevance. So the first network we studied was the default mode network. That is the internal awareness network. And here we see all the areas that they show a modification in connectivity, moving from healthy controls to minimally conscious, vegetative, and coma. So these areas tend to diminish their importance in patients as consciousness fades. And more recently, we studied both networks together, the internal and external in patients. And then we wanted to see whether this internal-external functionality would characterize also patients with disorders of consciousness. And we found that this anticorrelation happens only in conscious conditions. So here, for example, we see healthy controls, right? And patients who exited the minimally conscious state. So these are also healthy patients, but severely disabled. And let's focus here on the negative connectivity, the anticorrelations. We see that they are present once you are conscious, but once you are unconscious, there is no such thing. It even comes positively correlated, pathological positive correlations, as we say, between the external and internal system. But during rest, you don't only have this double functionality. You can actually cover many aspects of cognitive function. You can have, for example, 10 different networks that they can describe your cognitive function. You can have large scale that would cover more high-level cognitive processing, like, as we said, the default mode, the executive, control left that about the environment. Then you have a salience network that is important for detecting something interesting in the environment, like pain, right? And then you have also sensory networks, like motor, auditory, visual, and cerebellum. So when we have this model in healthy people, how do we go to check it with patients? I don't want to go into details, the technical details. I would love to discuss technical details if you're interested later on. But here I will show you that out of these 10, we found that 4 of them, they were severely modulated in disorders of consciousness. So here we see the number of patients and healthy people that they show the left executive and the right. So this is the frontoparietal, the external network coming in two. The DMN, and interestingly, the auditory, that was less often identified in patients than in healthy people. But this goes all fine when it comes to the science of it, but patients don't go in groups to the doctor, right? They come one by one. So what is the clinical relevance of this work? How can we use the resting state paradigm in order to differentiate the patients? So what we did, we worked with machine learning algorithms. That is like we tried to separate, based on the data, the two different groups. And we succeeded to separate healthy from patients based on the information whether a network was of neuronal or non-neuronal properties. And neuronal meaning that at least the fluctuations of the Bolt signal of the fMRI is similar to that of the controls. And we got quite high accuracy that mainly came from the default mode network and the auditory that did the best job to say that, okay, this is a healthy person and this is a patient, right? But to differentiate these two categories was still a problem. And in machine learning, defining the discriminative feature, the thing that would say that this patient is like that or the other, is the challenge itself. So we went on in trying to find which is this characteristic. And this time we checked the three large-scale networks and three sensory-related networks. Here just show you the connectivity that is in healthy people, MCS, VS, and coma. And we see, like as a first read, that the connectivity diminishes as consciousness diminishes. So without, again, being into details about how we arrived to this conclusion, but when we asked which is the network that would best differentiate between VS and MCS, we found it was the auditory. And I call it here auditory because it's mainly named as such in the literature. But if we see better, we see also visual areas and mid-cingulate areas, that the connectivity between these and the auditory systems here was the thing that discriminated between these two conditions. Here I show it better. These are the areas that are more connected in minimally conscious than in vegetative state patients. And when we have a classifier that says, okay, this patient is on this side or on that side, we imagine that there is a separation line that discriminates these two classes. And then if we measure the distance from this plane, this decision plane, on this side, we can have patients that they are classified as minimally conscious and here as vegetative state. So what we did is that we trained this machine to separate between two classes on one data set, and then we used patients that they were scanned into other different centers with different parameters. These were centers at the Cornell University and Salzburg. And out of the 22 patients, we found that the two were misclassified. So 20 out of 22 were correctly discriminated, meaning that the doctor and the machine were in accordance with each other. Interestingly, so for example, this patient that was that came to us, at least had the label of minimally conscious state, was classified as VS. But when we checked what happens with this patient clinically, this patient was diagnosed as MCS based on localization of pain. And that was found in only one assessment out of many. And this patient who came to us as vegetative was misclassified as MCS. And interestingly, 30 days after the scan, he evolved into an MCS, meaning that this technology could be a bit of predictive information. And this is the scientific part of it, trying to make a sense of why this cross-modal thing between visual and auditory systems why it works in patients. Previous studies identified that these areas, this an fMRI, were recruited when we are more attentive of what happens around us. Attentive of especially mistakes. Are you familiar with the Oddball paradigm? So the Oddball paradigm is like you have regularities and then you have an irregularity out of it. And then your system will capture it. Here the paradigm was as such. People were hearing two sounds. And we use that all the time in the clinics in Paris. That's why I'm spending more time here. So it goes like that. Beep, 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 beep. 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 Right? And this oddball thing would capture your attention. This can happen. You can manipulate at the local level, whether it's beep, 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 so it becomes irregular or not. Thing is that your brain will capture it. And when we are attentive, conscious to that, then this connectivity is recruited. And interestingly, when you check how these cross-modal connectivity changes in an anesthetized condition like in propofol, we find the following. If we check just the visual system in the awake and anesthetic state, we find no differentiation in the connectivity. Here we see, for example, this is the connectivity strength in the wakefulness, mild sedation, unresponsiveness and recovery from anesthesia, and we see that the modulation is not dramatic, neither for the visual or the auditory system. Whereas when you measure, here you're measuring the visual, and then you see the effect of the auditory, we see that the modulation is profound, and that it comes back once you recover from anesthesia. So trying to, we think like every week we deal with these things. Like we discuss a patient that is referred to us, and then we try to make sense of their consciousness level by trying to combine different modalities. So I have, for example, the fMRI part. My colleagues have the EEG part. Others have the PET scan. And by trying to put everything together, we're trying to say, okay, this patient most probably had some covert awareness or not. And the difficult part comes when you have to communicate the results with the families, right? Because as a researcher and as a clinician, you go to them and they don't care about discussing connectivity here and there. The question is simple. Is there anybody in there? Because like that, we can take decisions. Are we going to continue treatment? Are we going in rehab? Are we going to stop treatment eventually, right? So for the moment, we cannot be 100% recommend that this tool would be the consciousness meter of a patient. Because still it's research, we're trying to apply it, to generalize it to other data sets, yet we can get information out of it. So here we can have the results of the test and the cases where these can have beneficial effects or harmful effects. So let's examine these scenarios. That the brain activity that we see by the technology is less than that observed by neurological examination. So the effect would be like for the relatives, this would be an incentive to decide to limit life-sustaining treatment, right? On the other side, the relatives may lose hope and meaning in life. What if the brain activity of the technology is higher than the neurological examination? In that case, the clinical management may be intensified by the chance of further recovery, or the relatives will end up having false hopes, expecting all the time something to happen. And ideally, we want to reach this point where the neurological examination and the technological assessment would match, so machine and human as close as possible. Because like that, the clinician and the relatives may be affirmed in their decision about the level of treatment, or when it comes to the harmful effects, may be disappointed, and treatment cost effectiveness may be poor. I don't know, yes, I have some more time, because all these studies I mentioned here, they come from a third-person perspective, the clinical neuroimaging, meaning that patients are not there to discuss with them what happens, right? We have to infer what happens with them. And most importantly, when it comes to neuroethics, we don't have their own consent. Consent is coming from their relatives and their families. So, I don't know what is not playing, but this is just the case of locked-in syndrome. So locked-in syndrome is not a disorder of consciousness. Locked-in syndrome is a very restricted motor condition where patients are fully conscious, but they're not able to show it because of mainly infarcts at the pons during a stroke, for example. The most famous case comes from the movie, right? You know, the Scaphandre les Papillons? It's the most famous case of a locked-in patient. So with these patients, unless we're talking about complete locked-in, where you cannot even move your eyes to communicate, we can have some means we have ways to communicate, either by brain-computer interfaces. Here, it's a simple eye tracking device that gives autonomy to the patients to express their feelings and their cognitive content. So what if we ask them about issues that we are concerned in answering in patients? What happens is that as a healthy person, you have different beliefs about a condition if you imagine that you are in than when you're a patient yourself. So here, it was a study we did with locked-in patients. And here we see the number of respondents of locked-in patients and healthy controls on the question whether your image as a cell, your self-image, has changed after the accident. And here we asked the healthy people to imagine that they are patients and whether the self-image would change after an accident. And we see that patients in locked-in syndrome, they said that pretty much it's the same me. And when it comes to quality of life, we asked, again through questionnaires, patients in locked-in syndrome to rate their quality of life in the following way. That was very fun, and we can even do it together. We asked them to imagine the best period of their life that they ever had, and coin it with +5. Let's say your paper is accepted in Nature, okay? And you have to imagine the worst period of your life and coin it -5, like your paper being rejected by the local journal. And then they had to give a value of how they've been the last 2 weeks. How many would you say, if we say this is the border, how many would you say the majority of locked-in would say that they are above 0? And how many of you would you say that the locked-in patients would score below 0? Wrong. The majority of locked-in patients professed a good quality of life. And only a minority said that they did not lead a meaningful life that would of good quality. This is the misconception we felt here just now, right? When it comes to those that they professed, only minority asked for euthanasia, and the variables that associated with a good quality of life were the ability to talk and to be useful in the community. And the longer you are in this state, the more time you have to recalibrate, let's say, your resources, and then eventually being given a adjustment, to have good adjustment and find meaning again. And then you can do all these wonderful things, like write books, your memoirs of what has been into this condition. So going toward the end, I would like to say that technology is part of our lives, and it especially when it comes to clinical research, it influences or it can influence our attitudes toward clinical conditions. Here we see, for example, as a function of time, the number of publications that they've been using the different technologies. And we see here that after the new century, by means of technology, we're able to better understand the minimally conscious state and categorize it as minus plus, redefine the vegetative state, like unresponsive wakefulness syndrome, because like that we refuted the standard thing that vegetative state, there is no recovery there, that was in the past. And even define the functional locked-in syndrome. That means that these are locked-in syndrome patients that they can communicate only by means of technology, but no other motor-related activity. And in the end, coming from issues and questions of medical and ethical content, we're trying to define the biomarkers by means of neuroimaging, let's say, in order to define the prognostic, the diagnostic and prognostic use, and that would eventually feed back those medical and ethical questions that would promote our understanding of these conditions and being more capable to talk about the clinical, scientific, and ethical counterparts of dealing with these challenging patients. This is some of the issues that we can consider stemming from this, from studying patients with disorders of consciousness. For example, the moral significance of consciousness, meaning that if you equal consciousness as personhood, then there's the issue of moral agency, or the relationship or contextual understanding. So this means that patients have values for others. That's why we should be going on with the research and intensifying our efforts for recovery. Another point that we could possibly discuss is the legal challenges. For example, for using brain-machine interfaces like the tennis paradigm. What if we ask the patient, would you like to be kept alive? And the patient said no. How can we take that as an answer and respond to this question? And when it comes to the cognitive neuroscience about the brain or mind reading, to what degree do we neuroscientists have the right to interfere with the patient's intimacy, such as cognitive contents in the absence of their consent, like decoding dreams or decoding any other mental thought? In essence, where do we draw the limits of deciphering another person's cognitive content? And what is the additive value to this societal level? And I'm so happy that we can discuss all these things potentially in the next minutes. Thank you so much for your attention.
Thank you, Athena, for a very interesting talk. Questions?
Thank you very much, Ron. My question is directed to the quality of life of the LIS patients. How much of a bias is in there? Because many of these patients choose to die beforehand, before you can talk to them. Physicians and relatives and even patients, if it comes to lock-in state, often the machines are just switched off. You don't have the chance to talk to these patients. So what you have are the patients who restrict, the patients and relatives who restrict from switching off the machines. Mm-hmm. So is there a bias in these results about quality of life? So maybe the locked-in patients with the worst quality of life are dead anyway.
Mm-hmm. If I understand correctly, because here with the patients that they were recruited from the Association of the Locked-in Syndrome in France. And many of them, they had been in this condition even, I think the highest was in 28 years. So the majority of them, there are those that they've been in this condition for long years, so that's how we calibrate it. I don't remember how many of them they used just technology in order to communicate. So in that case, the switching off and on, I don't know how much of that issue would be. You maybe have more experience because you deal with amyotrophic lateral sclerosis patients, right? And these, I think this has a different clinical condition, picture, because it's progressive up to as compared to patients that had a stroke. That is something very profound. I don't know what is your hypothesis behind it, because I'm sure you're thinking something when you ask this question.
Well, if there is a bias, if the patients with the worst quality of life, you cannot ask because they are dead. I mean, you're right. I was for amyotrophic lateral sclerosis, where many patients die and are letting die.
Yeah.
And if these have the worst quality of life, you don't have these pictures within your data.
I'm not aware of something like that. If I have something, if the picture is like that, maybe I don't understand your question. Absolutely.
Allow me to ask a question. Athena, when I read the title of your talk, it just came to my mind something that I have read just a few weeks ago about that recently a US biotech company has been granted ethical permission for a highly controversial clinical trial to attempt to stimulate the nervous systems of 20 brain-dead patients in order to reverse brain death by intrathecal neurotransmitters, stem cells infusion, and transcranial IV laser. And I don't know if you are aware of it.
No.
But however far-fetched this may sound, I would like to ask you if you consider if this is possible, and then what are the ethical considerations of this matter for the individuals, for the patients, their families, and the society.
Did you read that in papers, like in the news? Because
yes, but it's a clinical trial.
Because
clinical trials.gov.
Because in many cases, the media have a misconception about brain death and vegetative state, right? And these are completely two different things. Brain death is death. Is death because your brain doesn't work. If you measure it by PET, post-emission tomography, you find no metabolic activity whatsoever, although in unresponsive state we do. So in that case, bringing life to a dead brain or body, to me it sounds far-fetched because there is nobody coming from death to say that, so far at least to my knowledge, that can confirm that. But it sounds very, very strange, right?
I heard of this experiment I think it's in the paper, is it serious or not, but I think it comes from bioconservatives that hope to resuscitate, they speak of resuscitation. So maybe it's a matter of contesting the criteria of the
brain death, exactly.
I think there is a political agenda behind that.
It's possible because brain death indeed has clinical criteria. There's specific clinical signs that evidence it, like flat EEG, like metabolites that their excess are there. So it's death. So I don't know whether they succeed. That would be interesting, right? The ethical consequences, I think they're out there, concerned in everyone.
I just want to take, I know this is hypothetical, but I just wanted to ask the further question, which is interesting to me, of whether you can actually harm a dead person by bringing them back to life. So if you come to the ethical legal question, let's assume it were possible with this intrathecal stem cell, whatever, that you could reactivate and create some sort of activity in the brain of a formerly dead person. Would that constitute a harm, ethically and legally, to do that to a person? Then I'm thinking of case law. This is in the Canadian, American context of the so-called wrongful birth kind of litigation. So this would be something like a failed sterilization or a failed abortion, and then the child later is born damaged and sues, and the courts are unwilling to say that that's a harm to have been born in a damaged state. So in a way, you cannot be harmed by being given a damaged form of life. So it would seem to me, if it were possible to reverse this death, you would not be harming a person by bringing them into that very disabled state, presumably. Anyway, it just
unless they ask for assisted suicide, right?
Yeah, that would be hard too.
Yeah, that would be harmful. No, keep me dead.
You mentioned the fact that there's big difference in the auditory cortex, between patients and controls. And I was just wondering if it's a good idea or not, just or someone did it, or you ever think about just passive listening of sounds or voices, if they recognize familiar voices of the relatives. Or...
Absolutely, you're absolutely correct. These are the manipulations, experimental manipulations that they are done, like sending very neutral stimuli, like auditory clicks, or baby cries, or speaking, having your name, hearing your own name, and even more hearing your own name by a familiar person, let alone by yourself in the past, right? These are stimuli of emotional valence, that is salient valence. So like that, you increase the chances that, as with a visual pursuit, that you're tracing your own self in your own image in the mirror, you increase the chances to capture something, at least a statistical level. Yes, there has been research into that. Indeed, minimally conscious state patients would respond to the emotional valence, stimuli with emotional valence more than the vegetative state. And in many cases, within this research, and when I review papers, it's like, okay, we did this study. Let's say we presented their own name by a familiar person, and then we found that 10%, 10 out of 20 vegetative patients, they responded. Again, for me, it's like, okay, you say that 10 of these patients in vegetative state responded, but how many times did you evaluate in order to arrive to the diagnosis of vegetative state? Because maybe if you did only one evaluation, you just capture the MCS being the unresponsive part, right? And this kind of says, okay, these patients have extra cognition that we could not capture by other means. So what I want to pay attention to put the attention to is like, you need a very clean clinical baseline that comes from the behavior evaluation before you enter into the research and doing all your stats. That is a big confound.
As I understand, both of these, the minimally conscious state is a continuum. It's not just one state. You can have, within that category, different levels of consciousness. Is that right? And can you evaluate that using this kind of approaches or not yet?
You mean neuroimaging?
Yeah.
Yes.
Or other?
The MCS plus and minus, that's what you're referring to, right?
Those I imagine that there's even more graduation than just plus minus within that category. No? I mean, you can be just kind of aware and be able to respond yes or no, and you can have the ability to have a complex thinking, and between the two there is a huge difference, no?
Concerning the formal categorization, for the moment we don't have like something continuum. It works very nicely to think binarily, MCS plus or minus, although you can have fluctuations between these two, right? We take the highest behavioral sign as the one that determines the condition. So once you show command following, then you are, for example, MCS plus. For clinically, maybe for research purposes, you can have different definition. But whether there is something in between that between these two conditions, or you mean higher than that? Higher if you are able to show that you can communicate yes, no responses, this is the minimum, with your environment, then you're not MCS of consciousness. But you need, based on the formal criteria, 2 signs in order to have that. Either functional communication or functional use of objects. So if I give to the patient a brush, a hairbrush, they have to do this thing on themselves or another person. And then if I give them like a cup, they have to show me that they know how to use that. You see, it's very, very challenging. You realize that. That's why we are trying to understand better the brain function. And sometimes this distinction between what a doctor or a clinician says and what the machine says, this is what we're trying to put closer.